Have you ever wondered what the sweat on your skin has to do with a giant supertanker crossing the ocean? It sounds kind of like a riddle, right? Well, the answer is a truly revolutionary piece of science that basically powers our modern world. Today, we're going to dive into the science of cold. Seriously, think about it. You know that amazing feeling of relief when a breeze hits you on a hot, sticky day? That's not magic, it's pure physics. And you know what? If you can understand that one simple sensation, you've got the key to unlocking the entire science of refrigeration.
The scientific name for this is evaporative cooling. Here's how it works. For a liquid to become a gas, for sweat to evaporate, it needs a little kick of energy. And where does it get that energy? Well, it literally steals heat right from your skin. As that heat gets pulled away, you feel cooler. And believe it or not, that single natural process is the blueprint for every fridge, freezer, and air conditioner on the planet.
All right, so let's start at the very beginning. We're talking about nature's original air conditioner. Way before we had any fancy machines, people were just smart observers. They looked at the world around them and at their own bodies to figure out how to beat the heat.
And that simple observation, well, it led to one of humanity's very first bits of cooling technology. It was simple, it was elegant, and yeah, it used the exact same principle as sweating. Folks in ancient civilizations, especially in really hot, dry places, figured something out. Water that was kept in porous clay pots stayed remarkably cool. But why? Because the pots themselves would, well, sweat. Just a tiny amount of water would seep through the clay's microscopic pores to the outside surface, and poof, it would evaporate, constantly pulling heat away from the pot and cooling the water inside.
And this is where it all just clicks into place, right? On one side, you've got our skin, with its pores releasing sweat. On the other, a clay pot, with its pores releasing water. It's the same mechanism. It's such a perfect example of us humans being clever and just copying a blueprint that nature had already perfected.
Okay, so natural evaporation is pretty cool, but let's be honest, it's got its limits. It can be slow, and it really depends on the weather. So the next big breakthrough, the next giant leap, came from asking a really important question. What if we didn't have to just wait for this to happen? What if we could control it?
And that question, well, it sparked an absolute revolution in engineering. It's called the vapor compression cycle. This thing is the workhorse, the engine that powers pretty much all modern cooling. And honestly, it's just a fascinating bit of physics.
Now, this is where things get really clever. Instead of just letting evaporation do its thing, engineers figured out how to basically put it on steroids. By using a special fluid in a closed loop, they could force it to evaporate and condense over and over again on command. This completely changed the game. Cooling went from being this passive process to an active one, a system for grabbing heat from inside a box and dumping it outside. I know, it might sound complicated, but it's really just a four-step dance. First, the compressor squeezes the refrigerant gas, making it super hot and high pressure. Second, that hot gas flows to the condenser coils, the ones on the back of your fridge, where it releases all that heat into your kitchen and turns back into a liquid. Third, that liquid gets forced through a tiny nozzle called an expansion valve. The pressure plummets, and boom, the liquid gets intensely cold. And finally, that freezing cold liquid enters the evaporator inside the fridge. Here, it absorbs all the heat from your food, boils back into a gas, and starts the whole cycle all over again.
And that evaporator step? That's the real magic right there. It's the heart of the entire process. It's the modern, mechanical equivalent of sweat evaporating from your skin. It is the exact moment cold is created, precisely because heat is being yanked out of the air inside your fridge.
Now, you can't just use water for this, of course. The whole system relies on a special substance called a refrigerant. You've probably heard of things like Freon. These early refrigerants were so effective because they had all the right stuff. They boil at really low temperatures, they turn back into a liquid easily under pressure, and they don't corrode the pipes.
So, we've made the journey from our own skin to clay pots, all the way to the fridge in your kitchen. But trust me, this technology doesn't just stop there. It scales up, way up, to power massive industries in some of the most demanding environments on Earth.
Just look at the global fishing industry. Refrigeration on those massive vessels is an absolute economic lifeline. It preserves the catch, prevents spoilage, and allows ships to travel farther out for longer periods. It's an incredible feat of engineering. But what if you needed to get something even colder?
How about negative 162 degrees Celsius? Let that sink in for a second. That is just unbelievably cold, colder than any natural temperature on the entire surface of the Earth. So why on earth would we possibly need to achieve a temperature like that?
Well, the answer comes down to one word: logistics. Natural gas in its normal state takes up a massive amount of space. But if you can chill it all the way down to minus 162 degrees Celsius, it condenses into a liquid that takes up 600 times less volume. This breakthrough allows us to ship immense quantities of energy across oceans in specialized supertankers, all thanks to some of the most powerful and sophisticated refrigeration systems ever built. And just like that, our story comes full circle. It's the incredible journey of a single, simple idea, scaled up from a basic biological function to a cornerstone of global trade.
I mean, just think about the journey of this one idea. It starts as a simple biological observation. Sweat cools us down. That inspires an ancient technology, the sweating clay pot. Millennia later, engineers capture that same principle in a machine, the vapor compression cycle. And today, that same core idea allows us to shrink a gas 600 times to ship energy around the globe. It's a perfect, unbroken line of human ingenuity.
So the next time you feel that cool relief of sweat on a hot day, remember the incredible journey of that idea. It reminds us that the solutions to our biggest challenges might just be hidden in the simplest observations. It really makes you wonder, doesn't it? What seemingly ordinary thing that we see every day holds the key to the next world-changing breakthrough?